Okay, so good evening, good morning, good day, everyone. Yeah, a short announcement from Search Engine Group. Actually, I already posted this on Slack. We have a small delay with V30 because I have another commitment that I need to finish by tomorrow. So probably if I'm going to run V30 pipeline for V30, it will be on Thursday. Unless somebody else wants to jump upon it and run the AWS instance just for V30. So just please notify me if you like it. And we have also our friends from I think from which task is it? Anton?
I think I'm mainly task ties, right? Right, guys?
Yeah.
Alex,
Guys, yeah.
Shrida,
Yeah.
and oh, we actually got a lot of people from task ties. It's a task ties call now.
Okay, good. And the idea is actually that to talk a bit about entity recognition, things that actually our pipeline can provide, and how we can merge this with requirements coming from the ties task. Yeah, that's ties task. Okay. Sorry, what, Anton? I didn't.
Task ties. Like we have all of this different naming schemes that get mixed up in the end.
Task ties. Okay, yeah. So in this way, I'm improvising now because I don't know where we can start in the sense.
Lucas, I think you should explain what we already have.
Okay.
And let's see where we can collaborate. I think guys already produced some interesting custom models that can be integrated also.
Yeah.
Okay, so at least now what Search Engine Group has provided is a so-called Brandon, like a new version of Brandon pipeline. It's an annotation pipeline with 5 models from ScienceSpace. So it's large model and 4 other small, middle-sized models providing different types of entity recognitions, different types of ontologies. And build and with this pipeline we can annotate the whole Core19 corpus. The output is in JSON file, so each original JSON file, JSON paper file has its own annotated version with all possible lemmas, UMLS IDs, and different types of entity recognition items. Depending on the classification, depending on models you have on ScienceSpace website. So it's like a good reference point. So that's all. I mean, like, and then the next thing that probably we're going to do is like, and we are doing this. I think we feed that all annotated data set into Elasticsearch, and we want also to have a semantic search on the level of sentences, and we are going to do this as well. That, roughly speaking, that what we have and what we're.
Lucas, I think you are missing the most important thing here. So because Lucas actually made this pipeline to be run as parallel processes, so we are able to scale it up and we can produce results quite quickly. So I think you guys can be interested in this. And
okay, so yeah, it's like more technical. I mean, like that what I said was more theoretical in the sense what's the result, and a very important technical notice as Slava said is that it's a highly multi-process. And we need something like 24 hours, depending on the instance, 24 hours, 48 hours to run the whole Core19. And because we also we have also delta. I mean, like we use delta, so the difference between one Cort 19 version and another Cort 19 version to just to annotate those things that are missing. It means that actually we can update our Cort 19 collection on almost on every day, because on each day the differences between subsequent versions of Cort 19 are up to a couple thousands of papers and not 60,000 or 70,000. So it's also scalable, and it's already somehow, as it's designed by Slava, it's in terms of data management, it's sustainable. So we have a version that is based on a previous version of data, and we can also skip between those versions, and yeah.
Okay, so it would be nice if you guys can just tell us what you already have, and who actually can start. Alex?
Well, okay. Yeah, I mean, so let's see here. Let me just pull up this, because we actually just wrapped up kind of like a, so well, let's see here. Kind of some documentation on what everybody has just finished up. Oh, so I mean, at the moment, Shrida, Mahesh, Aaron, we're all working on still trying to nail down some of the sample size NER model, so to extract sample size. So that's probably something that we'd eventually like to include, you know, in this process that you guys have created.
Mm-hmm. Can you tell a little bit more about how you used the Kana to produce new annotations?
Yeah, so well, right now, so I used Elasticsearch to get kind of a subset of sentences that you know, relate to sample size, enrollment, dropouts, things like that.
Mm-hmm.
And then we've been annotating them manually to develop and feed them back into Spacey to develop that model.
Mm-hmm.
And so it's right now, the current state is just that it's not generalizing well outside of our subsample. And I think part of it is just the fact that there are so many sentences that don't talk about sample size that the model is getting confused.
My question, sorry for interrupting, is actually
yeah.
you reuse the science spacey model, or you are trying to build up your own, or you adapt just the.
I'm just developing a blank model right now. So I mean, one of the questions that I've had, and you guys probably know the answer to, is it going to be faster for us to implement a bunch of individual models or one large model?
It's a difficult question, because first, what do you mean with large? Because already in Science Spacey we have large model and we deploy it, and but we use also 4 other smaller models just to get like this name entity recognition items that are coming from different training data sets, and the annotation style is different. I mean, I'm not expert on those all biology expression language stuff, but when you look at the Science Spacey website, you see that those models are trained on different corpora, meaning that the annotation style is different. Another question is also how much those different subcategories of NER items, how much they are useful for our purposes. Because of course it's automatic annotation, and we talked already about it in our group with Slava and Anton, that sometimes you have misclassification, like things like chemical compound, and you have geographical names in chemical compounds categories. Like and actually I couldn't assign the, let's say, a kind of a accuracy threshold for such things? Because I don't know. I mean, like you have official numbers on the Science-Spacey website. You can look at you can look at those, but
Yeah,
yeah.
but Lucas, I think you are mostly talking about like performance
Yeah.
topic, but well, it would be nice actually to split models and to get separate files. And I think it's good for maintenance purposes if you want to fine tune models. So we can maintain all models separately in let's say in Dataverse. So we can release versions and we can fine tune, and probably we can get other groups, other teams from CoronaWhy also to work on the same models and probably to improve something.
Okay. So then I'll just continue to train either a blank model. Well, I'll do a blank model like I'm doing, and then we can just integrate it into the pipeline.
Mm-hmm.
Yeah, and my
okay.
additional question would be about like because you were looking just for a particular subset of sentences. Have you tried to work also with entity recognition to identify those signal words that are talking about sample size? I mean, like all this scientific parameters you're looking for.
Oh, so tell me if this is answering your question. So initially, like I was just using Elasticsearch, right? So I just picked half a dozen. So I worked with Christine. I said, here are the sentences, or here are the phrases or words that I'm going to pull out of Elasticsearch to get a subset of the data. She says, yeah, that looks good. Just because she does have some experience with medical literature. It's obviously not all inclusive, and it probably would, maybe there's a better way to get that subset of training data. I don't know. Does that address the question that you're asking?
Okay, because like your approach was to use Elasticsearch to identify this minimal subset of sentences of interest, and then use them to train a new model to identify all other sentences of interest that haven't been identified by Elasticsearch. And actually, because you work now like from the NLP perspective with certain n-grams, like word n-grams, like certain phrases that are signaling, okay, that there's a sentence about some scientific parameter we are interested in. And by entity recognition, actually, you recognize already those typical medical terms like sample size. And by using entity recognition of the whole corpus, like those trained from Science-Spacey, you can identify all possible sample size sentences in the whole corpus once they use those typical medical vocabulary. So you can use annotated data set like those V19 on V30 to try to find all sentences that mention, for instance, sample size, or I don't know what were words that you're looking for. But
so you're saying, identify the sentences by context?
No, like yes, okay, so it's my, because maybe I'm too long with my own pipeline, and it's like we have now annotated data sets. So every sentence, every section is annotated in terms of in terms of lemmas, in terms of named entity recognition, and in terms of different ontologies coming from different models or from Science-Spacey. It means that, for instance, to give an example, maybe I can share my screen, it will be easier. Just give me like 2 minutes, 1 minute maybe, because I need to find those things.
And meanwhile, I have a question for Art. Of course, we understand that all models that you already produced, they are kind of raw, so it's still experimental and it's not possible to use right now. But it would be nice actually to extend our pipeline this possibility to read any model, any custom model produced by any team. And it would be nice just to create this use case and to get something from you to our pipeline and test. So
Yeah, I've got a model developed already, so I can send that over to you
I
or
don't want
share that.
actually to send to me. I want you to publish in Dataverse.
Oh, okay. I'll
Okay.
Because actually it should work without manual interaction human to human, right? So we just need to publish something in Dataverse, and after to be able to read it automatically from API, so to get file content and to pull into our pipeline.
Okay,
Okay.
so I have already found this file. I share my screen. Wait, sharing. Okay, cool. So look, it's like a layout of annotated file coming from our new pipeline. So for instance, if we have a sentence like some ID of a sentence, then there's the original token like the content of the sentence, a community, respiratory, viral infection, blah, blah, blah. And then we have lemmas annotated with our function words because we are not interested in function words. And then we have, for instance, UMLS terms identified by by this big model of science spacing. So respiratory virus disease is benign, and it's based on all possible like medical vocabulary. So my presumption is that you have also like sample size or things like that are also grasped by such a model.
By UMLS, there are terms in UMLS.
Yeah, UMLS IDs, and then you have also a vector, like sentence to vector. Okay, that's like quite obvious. But then you have also different subcategories coming from those different science spacing models, like taxonomy or taxonomical or something, or diseases like diseases, herbs, or organism like blah blah blah. So I presume that once you have those your favorite vocabulary or favorite phrases for sample size or things like others, they should come up somewhere here, or lemmas or UMLS. So the most effective way would be just to run over the V30 or V19 and over those categories. I have already posted a notebook how you can surf over data set to get different types of categories, and you can gather all possible lemmas or all possible UMLS terms or other name entity recognition items. And then you can, each sentence is has its own unique ID. Each section has its unique ID. So you can do all possible machine learning or clustering, even very simple clustering methods, because it's already like on n-gram level. So it's like you don't need to mess up with all possible word combinations, because those data are already annotated. The only one thing is to have your own list of favorite words or phrases you are interested in, and to find those sentences that have those phrases, and then look up. Okay, it's everything that we want to have, or because for sure it's much more like informative than Elasticsearch, because it's already it's produced by multiple language annotation models. So it's in terms of contents and let's say information richness, it's much more than just Elasticsearch.
Okay, so the one thing that, so I believe that UMLS does have something about sample size. Some of the other terms I'm not entirely sure, like enrollment counts or dropout counts, which I know we may not have enough information on those anyways. I'm not sure, but
then
would you mind?
You have still lemmas. So I dropped out. Yeah, I left out just function words. So all possible nouns and verbs
Okay.
all included here in lemmas. So you can also do some n-gram lemma search, and it
Okay.
should work as well. And if my understanding is correct, we are going to fit this also in Elasticsearch. Then I need to talk with Pangeria about what kind of which ones of those categories we are going to fit into Elasticsearch, because you can say that we can use also UMLS terms as search terms in Elasticsearch, for instance.
Gotcha. Okay. I think I understand what you're saying now about getting those sentences.
And
Do you?
yeah.
Would you mind? Do you know where that is the? What's the title of the document that you created to
It's like
the notebook?
On CoronaWhy, it's a pre-processing V19, something like that, and it's one of the newest notebooks or newest repositories. It's on CoronaWhy, and in Dataverse, it's like Cort19 V19, something like that, and it's also should be somewhere at the beginning of the list because it's a new data set. So.
Okay,
Yeah, and
I'll check that out.
there is a Docker file, so you can build it, and
Yep.
easy to do.
Yeah, because there's a couple of dependencies. However, when you search through JSON files, you don't need any dependencies because the files are already annotated. You can use your own tools to go through, to search over those files, and to to explore items or categories that you need. So the idea is like you can work independently or from the pipeline, because pipeline is already pipeline did its work, its job on those data set, and the only one thing you need is your own notebook where you can do your own stuff, and you need just JSON reader in Python to read those things, and that's all.
Okay. Okay.
Yeah, and just don't forget that now we're in the process of updating of Elasticsearch, so all V19 will be placed in Elastic very soon, probably tomorrow or day after tomorrow.
Oh, really? Okay.
Yeah, so you can get actually all stuff from Elastic directly.
Okay. Yeah.
And if we will be lucky with latest version of Cort19, so probably on Thursday we'll get it processed, and of course we'll put it on Elastic as well.
Okay. Cool. Yeah. So that sounds good. So I guess kind of other projects that kind of fall in the same line. So Janice and Christine just finished up kind of a time period NER model. And in fact that one's already completed, so maybe that's even the best one to implement. I don't know what Janice is she on the call? No, it looks like she's not, but maybe we can reach out to her and have her implement that model. If she can't, then or upload the model to Dataverse, since it's ready to go.
Yeah.
Let's see. I think there may have been. Let's see. We got another that's working on normalizing section headings into generic categories. So you'll. I mean, I think you guys maybe have seen this, but
yeah.
I tried to sort by method, and there were all kinds of section headings.
Yeah, but I think there's some motive that we have for a very long time, because I remember that a month ago or something, there were some people claiming to want to work on normalization of section titles, but I don't know where this project has been stuck. So
yeah, I'll let me see here. I'll just,
because already Maya has asked me on that whether I know something. how to normalize. I mean, like
Yeah.
actually, this like in the pipeline, we normalize also. We try to normalize section titles, but in the sense that when we have like methodology, we change it to methods or something like that. Like it's like very simple character-based normalization, and
Yeah.
the more complex titles are not normalized, of course, because it's like they don't have any n-gram overlapping with some like with simple phrases like results or introduction or something like that.
Yeah. Yeah. Do so instead of normalizing, so apparently the clustering method wasn't working, is what she reported, and I just tagged you guys on that thread so you guys can see, you know, just kind of the list of projects that Tides is working on, or has finished. But I wonder if something like normalizing based on or predicting based on the text of the section text, has that been done?
No, I don't think so.
Or does that sound feasible?
Like, could you repeat exactly?
Well,
what?
yeah. So each section is going to be composed supposedly of several paragraphs of text. So if we, and maybe this takes some manual annotation, you know, but if we say here's a paragraph of text, and we label it, I'm thinking supervised, so we label it with the section, and we do that for you know, a couple hundred paragraphs or something, then we train it so that it will predict the paragraph based on or predict the section based on the paragraph.
It's infeasible due to the structure of JSON files from Cort19, namely sections. Like we have a different like sections have different paragraphs. That's true. Like you have like in this when you look into the structure of the both the original JSON file as the annotated JSON file, it's like you have a couple of paragraphs and they have the same section name, and yeah. But then the problem is actually which kind of data you want to use to train this model. You want to use lemmas, you want to use tokens, you want to use this already built vector sentence vectors or entity recognition items. What type of input data you want to use?
What about the body rows?
Body what?
Body rows. Wasn't there a body rows field in Mongo?
No, I mean, we are talking now about like JSON structure of the annotated data. And it's
I
like...
I think you guys are talking about different things. So
okay.
Yes.
our input is just JSON, and it has already chapters and sentences and other things. So
When you say chapters, what do you mean?
I mean, yeah,
Sections.
Sections.
He means sections.
Okay.
Yes.
Okay. So so if we use those, I mean, what if? So I mean, we can expand it. It doesn't have to be paragraphs if that's not what we can get, but we could do sections, and we without the titles, and we label them with those titles, right? Does that address the issue?
Yeah, I mean, like you can train this kind of classification model, but the question is from the like machine learning perspective, what the kind of data you use? I mean, what's the kind of data, like annotated data you use to train this model? Are you going to use lemmas? Are you going to use how you want to like to transform a sentence into some hidden vector or any kind of like numeric representation?
Yeah.
Are you going to do averages of all sentences or all sentences in a section? Because already I think that was Imran who worked on that, and they tried something with averaging sentences over sections or over paragraphs, but it didn't work. I mean, I remember this for sure, that averaging sentences over sections wasn't any like it didn't give any good results.
Yeah.
So,
Okay.
and I think that Brandon did that as well, and he tried that with different types of models to figure out whether it's possible to predict. I think to predict a section name from a sentence, but it didn't work as well. So
Yeah.
I think that in terms of machine learning, it's much more complex because I think that's you need some more sophisticated model than just to average all possible sentence vectors or just to some keywords. I don't think it works because very often information from one section is repeated in another section.
That's true.
But actually, this task can be quite interesting for another team. So recently we started historical data analysis and already published like 35,000 newspaper articles about Spanish flu. So it's mostly from 1919 until 1928 or something. And it would be nice to get this actually analyzed and to extract all these snippets related to Spanish flu, because obviously in news articles you have a lot of stuff, a lot of events, and you just need like small snippet telling something about how it goes with Spanish flu, and you don't need other things at all. So I definitely see value in what we want to do, and so
but still, it's like you need to think. Okay, what's the kind of data you need to accomplish your goal? In the sense that what the kind of like you have the whole section, and there's like a couple of sentences, even at 10, 20, 30. So a couple hundred of words. Which of those words contribute to proper classification? Which part of this whole information? Which piece of information is of value for your classification?
Yeah, but this is why you need actually to go from full text to split and to create annotations for like those snippets.
Yeah, but
but maybe you understand what kind of model you should build.
Yeah, that I think is like much more complex than just to gather all possible sentences and then label them and train some SVM or linear regression model.
But why not? I think it's quite interesting task.
Yeah, but it's already done by Brandon and by Imran. Imran tried this out.
I think what needs to happen is I think we just need to have further discussion on it. I think we need Radhana and like you were saying, Imran and some of these other people that maybe have I don't know if they've connected or not, but I think it's a good point that we need to figure out what's been done, figure out, so that we can determine what we could do moving forward.
Yeah, and I think that it would be good to have some like explanatory analysis of for certain sections types. Like if you have a section so-called results, then okay, which kind of words are dominant for such a type of section? Like maybe some signaling words, like I don't know, I cannot imagine what type of words or phrases it may be, but at least we need to know to identify this type of language that is typical for a result section.
I think all sentences with influence should be actually should be a source to create a model.
Yeah, I mean, like, it's like because it's not trivial. And even it's like maybe very often it's like from maybe from the academic practice that very often things like a summary or a results section is just like a repetition of everything that you already said in other sections, but just by making sentences shorter and to the point, so to say. But in terms of information, it's more or less the same that is somehow distributed over all other sections. For instance, and method section uses also maybe the full names of of certain methods or approaches, and that are later on in other sections, they are abbreviated. Things like that. But yeah, I think that it would, because we are already running out of the time, we need further discussion on that. For sure, we can talk about it on Slack. So everyone who has any ideas on that, or maybe who may know somebody else in CoronaWhy working on similar things, please contact us or please drop a line on Slack. Because we need at least to try on that. So to give a try to this.
I think it would be really helpful if we can make it work or get a good I'll see if I can connect a couple of people on that with you and Slava.
Yeah.
Okay.
So
yeah, go ahead.
Yeah, for sure we can make now use of those annotated data, and I think it's also it can turn to be very helpful, because a lot of things are already somehow identified in those sentences. So there is no need, like those name entities. So there is no need to build some special models for that. But the question is still how we can identify those like the signal words or signal phrases specific for different sections.
Okay, so we need to call Imran right now.
Okay, yeah, probably. Yeah, okay, so do you have any other question? I mean, maybe not other, but maybe related to this topic?
Yeah. No, I mean, the only other project that's listed here was Mike Honey's DataVis project, which I don't know if or how that would feed into the pipeline. I'm assuming, he's already talking with you guys though. So I mean, I think those are. Oh, no, Dimitro had a knowledge graph that he had been working on. I don't know if he had interfaced with you guys, and I haven't heard of any updates for maybe a couple of weeks now.
Okay, so he's not joining calls anymore, right?
I don't think he's on right now. I don't know if he's taking a break from CoronaWhy or what, but
Okay. So yeah, we can just contact and ask him about his plans.
Yeah.
So,
and I guess. Oh, sorry.
No, please finish your thought, Alex.
Oh, yeah. So I don't know if Christine Yang and Wendy Mack have anything to add. I think that the rest of us have covered any projects that we've been working on. So I'm all ears now.
Yeah.
So,
sorry to interrupt you again, but can you put your annotations also in Dataverse, because we're kind of missing all this stuff.
Oh yes, model and annotations. Yep. I'm kind of going back to complete to add some more right now, but next couple of days, yeah.
Okay. And I think
so
when you tried to say something.
So I've kind of built a study type classifier for I was working with Imran mostly, but the classifier, because we trained only on about just over 1,000 samples. It wasn't. I mean, I don't have a very high confidence in it, to be honest, but I think Thais did use some of it, the predictions in the end. So I think Christine needs to for the best person to ask, or someone actually working on Thais more. And the other part of that is that for each article that has a PubMed ID, you can also query PubMed for relevant article information. So kind of stuff around, say, what is a clinical trial, what stage of clinical trial, and then kind of there are other kind of categories that you can extract out. And the other part is that kind of initially I was thinking of using those as training labels for the paper study type classifier, but as it turns out, because we have various different annotations, and it's quite hard to like match the labels properly between them. So in the end, I didn't actually use the PubMed labels, but again, it's potentially something that might be interesting to add to the data set as such.
Okay, sounds interesting.
Okay, so other issues points I would propose, because like we have already much more over the time, that we can meet in 2 days on Thursday as well as a search engine group with guests from task task ties, and like the idea is like maybe we can gather like to have a small brainstorm on Slack, because I think there's a multiple things already discussed today. So when we want to keep this collaboration persistent, we need to identify like the hotspot things that must be done this week, next week, or ideas that can take a longer run, so to say. Yeah, because otherwise we have already experience in miscommunication between teams. So it would be good to get a kind of a like problem structure, which things we can fix now and which one are something that we need to work on longer run, on just in longer time perspective. Okay.
So quick, let me just again quick summarization. One point is for Wendy. You mentioned that like the classifier is not good yet, etc. And this is kind of like a generic suggestion. It's okay to have not like the best named entity recognition or the best classifier right now, because we only essentially have first iteration of any algorithm, right? Like specific data set, we build something. Then the idea right now is to essentially take the artifacts of those models, put into our infrastructure, like essentially pre-process the data on a scale, and then put it onto like Docano or Hypothesis. So now we have human annotators, curators to give us feedback on the results of that work. And then the next iteration, maybe the classifier will be much better, or named entity recognition model, etc. So like the whole goal of this collaboration is again not to like search engine team to take like all of the results of your guys' work and just simply like run with it. The idea is to simply, okay, we have this infrastructure that we could scale application of any model on any data, right? And if you did train your model for specific test ties, sub direction or something, we could still try to apply it for the whole data we have and then see, what we'll get from there. And you will get also, maybe we'll discover some other data set that will be relevant to your like specific focus, and we'll all kind of get this synergy going. So
it's going to happen if other teams will start to use the same models.
Yes, yeah. So that's kind of like the idea, just to take whatever. Let's say you have name entity recognition for like time something, right, from the articles. So you take the artifacts of that model, put it on the Dataverse. We have, referral to like authors of that model, where it came in from, maybe some GitHub repo with the code, how it was trained. Now that model will again apply, and maybe some other team would like to use that data, and then they will kind of refer to this, etc. So in a sense, we're creating this referral link system, citation of everything within like the whole organization, based on top of the data sets, model artifacts, etc., etc. And hopefully we'll get something really awesome from all of this. So please kind of start using Dataverse as a storage for like model artifacts and whatever data you produce. Because again, we already see people doing that, but not everybody is using Dataverse. And we need adoption of that like 90% plus, not like 75 or something that we have right now. So please upload your stuff from Dataverse, so datasets.coronawhy.org. And please join us next call so we can discuss more in details, because again, we had a lot of people on the call, but only a few people had the chance to speak.
Okay, so I would say we can finish this session. I mean, very fruitful. We hear, or we read us, so to say, on Slack, and we next meeting will be on Thursday, I think so. When everything will go as planned. Okay, so once again, thank you very much, and see you again next time.
Thank you.
Thank
Bye.
you everyone for your time.
Thanks.
Bye.
See ya. Bye.
Bye.